Good morning, students. So today we learn about partial derivative. So today we learn about partial derivative. Partial derivative. So what is a partial derivative? Okay. So you know derivative term. Okay, you know derivative term. So whenever you differentiate any function, say y is equal to sin x. Okay, say y is equal to sin x. Now if you differentiate this with respect to x, you will get dy by dx equal to what? Cos x. Okay, so here this dy by dx is known as derivative, or this cos x is known as derivative of sin x, right? Derivative of sin x. Similarly, if I take y is equal to x square, then if you differentiate, you will get dy by dx is equal to 2x. dy by dx is equal to 2x. So 2x is known as derivative of x square. 2x is known as derivative of x square. Similarly, if you consider y is equal to say x raised to 4 plus 2x square plus 3, right? So then if you differentiate this, you will get 4x cube plus 2x means it is 4x. Okay, so this is 4x. Then differentiation of constant, it is 0. So you will get dy by dx is equal to 4x cube plus 4x. So 4x cube plus 4x is derivative of x raised to 4 plus 2x square plus 3. So this is the derivative of x raised to 4 plus 2x square plus 3. Similarly, this cos x is the derivative of the function sin x, and this 2x is derivative of the function x square, correct? So this is known as derivative. Okay, then what do you mean by partial derivative? What do you mean by a partial derivative? Now see here, partial derivative means whenever there exists a function which is a function of more than one independent variable. So suppose that if z is equal to say f of x y, here z is a function of two variables. Two variables means x and y, two independent variables. There exist two independent variables, so that is more than one independent variable, so that is two independent variables, correct? So whereas in these examples, now see here, there exists only one independent variable, that is x, right? Only one independent variable, x, wherever it is, only one independent variable, that is x square. Here x raised to 4, 2x square plus 3, so that is only one variable, that is only x. So here the if you want to differentiate, so then only way is you have to differentiate with respect to x only, because there is no other variable, there is no other independent variable, only one variable, that is independent variable means x. So y is a dependent variable. Y depends on this x, because if you know the value of x, then only you can find the value of y, right? So therefore y depends on x. So x is independent variable, y is dependent variable. So always derivative is with respect to independent variable. Okay, always what we do, we differentiate a function with respect to what? Independent variable. So this is an independent variable, and we differentiate this y with respect to x independent variable. Now see here, all these functions contains only one independent variable. So this is known as ordinary derivative. and its differentiation is very simple. So just differentiate y with respect to x, so which gives cos x, and y is equal to x square. Differentiation with respect to x, it will give 2x, and here it is y is x raised to 4, 2x square plus 3, and its differentiation is 4x cube plus 4x. Only one independent variable, and you have to differentiate with that variable only. There is no other variable. So partial differentiation means what? When the function is a function of more than one independent variables, more than one independent variable. So here z is equal to f of xy. So x and y are two independent variables, and this z depends on two independent variables. So z is a dependent variable, and x and y are two independent variables. So now we want to find the derivative of this function. Okay, derivative of this function. So to differentiate, differentiation of a function which is a function of more than one independent variable, okay, so that is called as partial differentiation. So partial differentiation means what? Where we apply partial differentiation, or where we use partial differentiation. So we use partial differentiation when the function has more than one independent variable. A function has more than one independent variable. For example, in this case, z is equal to f of xy. So it is a more than one independent variable. X and y are two independent variables. So in this case, we need partial differentiation. Right? So here, to define a partial differentiation, let z is equal to f of xy be a function of two variables. Okay, so then limit of f of a plus h comma b minus f of ab whole divided by h comma as h tends to 0 if it exists. If it exists, then is said to be, if it exists, then it is said to be the partial derivative. Partial derivative of f with respect to x. With respect to x at the points a comma b. Okay, and it is denoted by dou z by dou x. Okay, dou z by dou x at points a b, or simply it can also be denoted by fx of ab. So here a subscript x denotes the differentiation with respect to independent variable. Okay, so that is fx means differentiation of f with respect to x. So fx of ab, or it is denoted by fx of ab, or it is also denoted by dou z by dou x at ab. Okay. Now similarly, again, if limit of f of a comma b plus k, okay, a comma b plus k minus f of ab whole divided by k as k tends to 0 if it exists. If it exists is called the partial derivative of f of xy with respect to y at ab, and it is denoted by dou z by dou y at ab, or it is also denoted by, it can also be denoted by fy of ab. Okay, so this is about the definition of partial derivative with respect to x and y, Okay, here dou z by dou y means what? Here we have to differentiate z with respect to y, keeping x as constant. So here, while differentiating with respect to y, we treat x as constant, remember. Okay, similarly, partial derivative with respect to x, that is dou z by dou x, means differentiation of z with respect to x, keeping y as constant. So this is very, very important. So because usually what you do, generally you have no differentiation with respect to x and y. Okay, ordinary differentiation, that ordinary differentiation means what? Only differentiation with respect to x, there you treat x as variable. Okay, so here what happened? While differentiating with respect to x, keeping y as constant, and while differentiating with respect to y, keep x as constant. So this is very, very important while solving the problems. Okay, so this is about the definition of partial derivative. Next, higher order partial derivatives. Higher order partial derivatives. So how we denote the higher order partial derivatives? Okay, so we know that dou z by dou x, okay, dou z by dou x or dou z by dou y. So these are known as partial derivative these are called as partial derivatives of order 1, okay. Next, if you differentiate one more time with respect to x, you will get dou square z by dou x square. Similarly, if you differentiate this with respect to y, then you will get dou square z by dou y square, correct? And similarly, if you differentiate this with respect to y, so then what we get? Dou square z by dou x dou y. Similarly, here this is dou z by dou y. If you differentiate this with respect to x, so you will get dou square z by dou y dou x, okay. So these are called partial derivatives of order 2, okay, of order 2. So like that we obtain partial derivative of order 3. So that is dou cube z by dou x cube, dou cube z by, okay, dou y cube. So if you differentiate, for example, if you take this one, if you differentiate this with respect to x, so what we obtain? dou square dou cube z by dou x square into dou y. And similarly, if you differentiate this with respect to y, then you will get dou cube zy dou y square into dou x. Okay, dou cube zy dou y square into dou x. So this is partial derivatives of order 3. So these are known as higher order partial derivatives. Okay. So in short, this can also be written as, I will write here, this can also be written as f x x, and similarly this one f y y, right? And here this is, I will write here, this one is f x y, and similarly this one f x y. Okay, f x is f y x, correct? So similarly this one can be written as f triple x, because we have partial differentiation with respect to x 3 times. So f x x x. Similarly this one f y y y, and here this can be written as f, here x 2 times, f x x comma y, right? And here it is f y y comma x. Okay, so like that we denote these higher order partial derivatives. Okay, so now we will see how to differentiate partially. With respect to x and y by solving some problems, right? So here, so take one example. If u is equal to x square tan inverse of y by x minus y square tan inverse of x by y, where xy not equal to 0, where xy it is not equal to 0. Okay, where xy not equal to 0. Now it is given that prove that dou square u by dou x dou y is equal to x square minus y square divided by x square plus y square. Okay, so this is the problem. So here dou square u by, this is dou x. Okay, so here this symbol dou, it is known as, read as dou. Okay, so here we have to show this. Now solution. Okay, so now what is given? First you write that. So u is given. So u is equal to x square tan inverse y by x minus y square tan inverse x by y. Correct? Okay. So now what we do? first we differentiate with respect to x. Okay, so partially with respect to x. So now differentiating, call this equation as 1. Now differentiating 1 partially with respect to x, okay. So what we obtain, dou u by dou x is equal to, okay, dou u by dou x is equal to. Now see here, we are differentiating with respect to x. That means we treat y as constant, right? Y as constant. So here this is x square and this is tan inverse of y by x. But here in this, that means what? In both the terms, in this x square and tan inverse of y by x is present. Okay, here also x is there and here also x is there. So therefore we have to apply what? Product rule. So keeping first function as it is, differentiate the second function. So differentiation of this is nothing but tan inverse x. So 1 divided by 1 plus y square by x square. Okay. Then again applying chain rule. So differentiation of y by x with respect to x means keeping y as constant. So differentiation of 1 by x is minus 1 by x square. So y is constant. Differentiation of 1 by x is minus 1 by x square. Okay. Then plus second function as it is, tan inverse of y by x. Differentiate the first function, that is 2x. Okay, 2x, right? Then minus. Now in this case, in the second term, observe here, in the second term we are differentiating with respect to x, means y is constant. So therefore this y square we write as it is. We don't differentiate y, because differentiation of, we are differentiating with respect to x, so we take y as constant. So keep y square as it is, only differentiate tan inverse of x by y. Okay, tan inverse of x by y. So that is, I keep y square as it is. Differentiation of tan inverse of x by y is 1 divided by 1 plus x square by y square into differentiation of x by y. Again we apply chain rule, but we treat y as constant, means 1 by y as constant. So 1 by y as constant. Now differentiation of x with respect to x is 1. Okay. So this means, now simplifying here, by taking this x square get cancelled. Okay. Then by taking LCM here, which gives x square plus y square by x square, this x square comes in the numerator, so which gives minus x square y divided by x square plus y square, correct? Then plus 2x into tan inverse of y by x, 2x into tan inverse of y by x. Okay. Then here, then this case, now here 1 y get cancelled. Okay. Then you take y square as LCM, so this y square comes in the numerator, so this becomes y cube minus y cube divided by x square plus y square, right? So this is equal to, now correcting the terms with similar terms. So this is similar and this is similar. In both the terms, x square plus y square is LCM. So x square plus y square is LCM, and it gives minus x square, then minus y cube, then this term 2x tan inverse of y by x. Okay. So in this we take minus y common, right? So which is equal to, I take minus y common, and in bracket I left with what? X square plus y square. So it is x square plus y square whole divided by this x square plus this x square plus y square. Okay, then plus 2x tan inverse of y by x, tan inverse of y by x. So this x square plus y square get cancelled. So which is equal to minus y plus 2x minus y plus 2x into tan inverse of y by x. So this is what dou z by dou x. Okay, or sorry, dou u by dou x. This is dou u by dou x. Okay, now differentiating with respect to y. Now differentiating this with respect to y. So then we obtain dou square u by dou y. Okay, so now differentiating, call this equation as 2. Now differentiating 2 with respect to y. So we are differentiating this again with respect to y. So this is becomes dou square u by dou x dou y, which is equal to, now we differentiate with respect to y, means we treat x as constant, correct? X as constant. So here differentiation of y with respect to y is 1, so it becomes minus 1. Then plus, we are differentiating with respect to y means x is constant, so 2 is constant, x is constant, this is 2x as it is. Now differentiation of tan inverse of y by x, 1 divided by 1 plus y square by x square, and again differentiation of y by x, but x is constant, so 1 by x is constant, differentiation of y with respect to y is 1, okay. So this takes the form, that is dou square u by dou x dou y is equal to, this is minus 1 plus, now here take 1x, x get cancelled. Now this taking x LCM, x square as LCM, and it gives 2x square divided by x square plus y square. Okay, so taking here x this x get cancelled, and taking LCM as x square, so x square is multiplied here, this x square comes in the numerator, so this becomes 2x square by x square plus y square, right? So now here 1, so now taking LCM again, this is x square plus y square, this is multiplied with minus of x square plus y square, then plus 2x square, which is equal to, now this is minus x square minus y square plus 2x square divided by x square plus y square, or which is equal to, now 2x square minus x square, it is plus x square, then this is minus y square divided by x square plus y square. Okay, so this is our dou square u by dou x dou y, dou square u by dou x dou y, so which is the required proof, right? So this we have to prove, and thus we prove this the required condition. So this is how we solve the problems on partial derivative, Similarly, we similarly, we take one more problem on this. Next we take one more problem on this. Second one. If u is equal to 1 divided by square root of x square plus y square plus z square, such that x square plus y square plus z square, okay, it is not equal to 0. So then show that dou square u by dou x square plus dou square u by dou y square plus dou square u by dou z square is equal to 0. Is equal to 0. Is equal to 0. Is equal to 0. Okay. So try to solve this problem, and this is, I will give this as an exercise, and I solve this problem in the next class. Thank you.